Well, I mean, maybe it makes sense to start by talking about the measurement problem. And it's, as you say, it links into those kind of realist instrumentalist themes. So here's my kind of quick summary of the measurement problem. Quantum mechanics is our best theory of the very small, but big things are made of small things. So really, quantum theory is our best theory of basically the whole of physics. It's amazingly successful, but we have serious trouble understanding the theory as a description of reality. As a sort of tool to calculate things, it works really well. But when we try to understand the theory, and often we need to understand it even to apply it, let alone to explain it or internalize it, it seems to be saying things that make no sense. So in particular, quantum mechanics seems to say that whenever something can have one property or another property, it can somehow have both of them at the same time. The thing that the technical term is superposition, but you can think about it as somehow having both properties at once. So if a particle can be here or there, it can somehow be here and there at the same time. If it can be moving this way or that way, it can be moving both directions at the same time. And while you could just say, okay, fine, that's subatomic particles, we aren't evolved to understand subatomic particles, maybe that's just a weird thing subatomic particles can do that we can't do. But the theory also seems to say that if you measure a particle that's doing two things at the same time, then that kind of weird superposition, two things at oneness, sort of magnifies upwards to the macroscopic scale. So if the particle's here and there at the same time and you measure it, then your measurement device says it's here and it's there at the same time. If you unethically connect the measurement device up so that if the particle is here, your cat gets killed, and if it's there, it doesn't, then if the particle's here and there at the same time, your cat is alive and dead at the same time. That doesn't seem to make sense. Even insofar as it makes sense, it doesn't seem to conform to our observations. You can kind of fix that in a very ad hoc way by saying, as soon as you get to the macroscopic level, as soon as you start talking about not atoms and molecules, but measurement devices and humans and cats, suddenly we don't understand quantum mechanics as saying two things are happening at the same time. We understand it as saying one of them is happening or the other one is happening, and we don't know which one it is. There's a sort of transition in how you understand the theory that's supposed to happen when you go from the small to the big. But that's very unprincipled. No one's got a good story as to how that is, or how it can be that the theory sort of suddenly stops working and works in a different kind of way. Because if you take really literally that idea that suddenly it stops being the two things are happening at the same time, what you're saying is that the equations of quantum mechanics suddenly have to fail at some scale, and then there's some random process that kicks the system into one way of being or another way of being. No one's ever found empirical evidence of that process, and it's very hard to build into our equations. But it's difficult to see how we can understand the theory without having something of that kind going on. That's the measurement problem. It's the problem that we don't seem to be able to make sense of our theories, and insofar as we can make sense of them, then we can only do it in very unprincipled ad hoc ways.
So just to reiterate, make sure that we're totally on the same page. So quantum mechanics is a very powerful predictive tool. I mean, quantum field theory has been verified up to 14 decimal points, I think, something to that effect. But there are these strange features of quantum mechanics that make it difficult to wrap one's mind around. So non-locality, the wave-particle duality, entanglement, all of these things. And to the extent that we can make sense, to echo your last sentence, of these strange features, it seems to have to be done, and to use your word again, a very ad hoc way.
Yeah, I think that's about right, yes. And those terms about entanglement and non-locality and the wave-particle duality you bring up, at the level of this discussion, those are all sort of different aspects of the fact that the theory seems to force us to understand particles as doing multiple things at the same time, and not simply doing one thing or another.
Right, which very much it does not reflect our macroscopic picture of the world.
Right, yeah, you have a cat, I think. I'm guessing you've never seen it alive and dead at the same time.
No, I haven't. There have been some scary moments where in the middle of the night I can't tell what's going on, but yeah, I've never caught her in the act of being alive and dead at the same time. So, okay, how do responses to the measurement problem align with maybe this landscape of instrumentalism on the one hand, pure instrumentalism on the one hand, and realism on the other hand. There are some finer grained distinctions. I talked to of course, there are plenty of finer grained distinctions. I talked to Lee Smolin on Sunday, and he threw magical realism in there as well. I don't know if you've heard this, but
I mean, here's how I'd think about it. Let's not think about the contrasts between realism and specifically instrumentalism. Let's just think of it as the contrast between realism and just the denial of realism. So realism, what I have in mind here, is something like our science is in the business of giving us a third-party description of the world. It says what's actively, objectively going on in the world. It doesn't say what's going on as perceived by a certain person. It doesn't say what's going on from the perspective of a certain person. It doesn't say what someone should expect to see or hear. It just says what's going on. End of story. So Newtonian physics is the paradigm case of this, if you like. Newtonian physics doesn't directly say this is what you should expect to experience. It says this is what's happening. And then there's a secondary epistemic question about what you should expect to experience, which is an important question to answer if you want to test the theory. But the theory itself is totally understandable, makes total sense, without the presence of the observing perspective. Indeed, you could understand the theory if there were no humans in it at all. And most of science is like that. I mean, our theories of genetics talk about the DNA molecule as just an objectively present thing with objectively present properties. It's not DNA for you or DNA for me. It's just DNA. So one class of solutions to the measurement problem drops that realist assumption in one way or another. So you might just want to be in a sort of out-and-out instrumentalist and try to say our theories are simply devices to make predictions, and that's the end of the story. You might want to say, a little more subtly, that our theories are intrinsically first-personal. There's a role for the observer that can't be separated out, that sort of Newtonian third-party concept of science just isn't adequate to the quantum universe. There's a bunch of different ways you might try to change philosophy so that the sort of flat-footed contradictions in the measurement problem go away. And alternately, if you want to leave philosophy largely unchanged, the natural thing people tend to think about is changing the physics. They want to say, okay, if the equations of quantum mechanics predict that cats are alive and dead at the same time, so much the worse for the equations of quantum mechanics. Okay, yes, 14 significant figure predictions, blah, 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 but nonetheless, doesn't matter how good the predictions are, it made the prediction there's a cat that's alive and dead at the same time. There isn't a cat that's alive and dead at the same time. The theory needs changing. So that kind of changed the philosophy and changed the physics route. That's how I tend to dichotomize. God, that's being very jargon, so sorry. That's how I tend to think about the choices in sorting out the measurement problem. Except that I'd say the Everett interpretation, the many worlds theory, is what you get if you decide, well, I'm not very happy changing the physics or the philosophy.
Do you think it is at all a fair, although reductive gloss to put on realism, to say that if one is a realist about the theory, then one takes a somewhat Quinean attitude toward it and feels committed to the sorts of objects and processes the objects it quantifies it over, or the processes it describes?
Interesting. I mean, yes and no. I mean, I think it's sympathetic to the very general sweep of Quine's perspective. In other words, the realist says, here's my theory. This is what my theory is saying. I have no better guide to the world than what my theory says. I have no better guide to epistemology than the scientific method. So if this is what my theory is, then that's what I'm committed to. Whether you want to follow Quine further into the kind of our goal should be sort of regimenting our theories in a first-order logical framework and then committing to the quantificational claims they make, I'd say that's a substantive assumption about what our theories would be telling us that Quine's making. I actually think Quine's probably wrong for reasons that are a bit at right angles to the many worlds theory and to do with the way we use mathematics to represent. And I think that kind of what are we committed to quantifying over presupposes certain things about the way scientific theories are stated that Quine is just wrong about. But I think the broad Quinean spirit is absolutely very sympathetic to that sort of realist position.
Just to
by the way, sorry, just pausing a second since you can edit this. I was answering that one at a relatively high level because you moved into the philosophy point, but I can I wasn't sure quite at what level you wanted an answer to that.
Totally fine. No need to think it all. I try not to think these things over too intensely. Just wondering if what you have in mind is anywhere in the ballpark of you just don't want to be. You don't think that using math in physics, for instance, commits us to the existence of mathematical objects. They're just sort of a descriptive tool.
So I think something slightly different from that. I think that, I mean, this is a slightly different topic, but it's interesting in its own right. I think that the way physicists use math to model the world, while it can be cast into a kind of object property relation language, normally can't be uniquely so cast. And trying to do that tends to lead us to try to draw distinctions that physics doesn't really care about. So, for instance, physics talks a lot about fields, and what's a field? Well, you might want to say, look, a field, when I say there's a field permeating space, you could say, well, I mean, there's a sort of physical entity, an extended thing, and the parts of that entity sit in parts of space. Or you might mean, well, field is a sort of façon de parler for saying that all the entities in the world are the points of space, and the points of space have field properties. So in the one case, your ontology includes both the points of space and the parts of the field, and your ideology includes a whole bunch of occupation relations. On the second version, you've got a much sparser ontology, just the points of space, and a different ideology that just consists of field strengths. According to the sort of classic Quinean way of playing the ontology game, those are sharply different positions, and metaphysicians argue about which is right. Physicists don't give a damn between those positions. They're mathematically equivalent. The math that you'd use to model the one and the other are the same or intertranslatable by translation schemes that physicists don't regard as content changing. So, in my view, if you want to say how do we read content of physics, you're led to something a bit more structuralist, a bit closer to the sort of structural realist ideas that have been in vogue in the last 20 years or so, and a little less Quinean.